do another lesson on solving equations, but I want you to notice the little parentheses underneath it. Now we're going to deal with equations where we have variables on both sides of the equal sign. So last time we were able to at times simplify both sides of the equal sign, but then we didn't have this section. Today we will. So we're going to deal with variables on both sides, and then we'll do what is keeping the variable from being isolated. So I want to just zoom in and talk about what to do with situations where we do have variables on both sides of the equal sign. A lot of students deal with their constant terms rather than their variable terms first. I found just from experience teaching algebra that a lot of students will avoid confusion if they deal with their variable terms first. So I want you to notice what it says right here. You want to get them together by adding or subtracting the entire term. So I'm going to zoom in right here on that. It's a little pixelated. But notice the original equation had a minus x on the left and a 3x on the right. Well, we want to get rid of that negative x or minus x, so we're going to add x to both sides. And then at that point, if we go into that next step, we would just have a 5 is equal to, and then 3x plus x would give us a 4x, and then plus 9. And now it looks like an equation that we've seen before from the previous lesson. So let's go ahead and do some examples. I'm going to continue to talk you through the exact same process we used on the last video. So I'm going to go ahead and make my two sides very obvious. And then the first question I'm going to ask myself is, can I simplify the expression on the left side of the equal sign? To that I say yes, I've got the ability to distribute here. So I'm going to multiply 5 times x and get 5x, and 5 times negative 4 and get negative 20, and then just bring down my positive 8. I can still simplify by combining these two like constant terms and get 5x minus 12. On the right side, I can also distribute. Notice there's a minus and then a parentheses. What that means is like you're essentially distributing a negative 1 to both terms in the parentheses. So we end up with 3x minus x, or minus 1x if that helps you, and then negative 1 times positive 2 is negative 2, and then we can combine these two variable-like terms. So 3x minus x gives us a 2x and then minus 2. All right, the next question we want to ask ourselves is, are there variables on both sides of the equal sign? And there are. We have a 5x on the left and a 2x on the right. So what do? We need to subtract 2x from both sides. You could, it's not wrong for you to subtract 5x from both sides, but then you're going to have a negative variable term, and negatives are just notorious for causing careless errors. So I usually try to keep my variable terms positive if possible. So I'm going to, because this is a positive 2x right here, I'm going to do minus 2x, because 2x minus 2x is 0, and then whatever I do to one side, I do to the other. So 5x minus 2x gives us a 3x, and then I can bring down my minus 12. But on the right side, this is canceled, so I'm left with a negative 2. Now, what is keeping the variable from being isolated? We've got a 3 that's being multiplied and a 12 that's being subtracted. We deal with addition and subtraction before multiplication and division. So I'm going to add 12. Whatever I do to one side, I do to the other. Now I bring down 3x is equal to, the negative 12 plus 12 cancels, and I end up with a positive 10. And now I divide both sides by 3 and find that the value of x that makes the equation true, or I could say the value of x that satisfies the equation, or whatever the number that x is that you can plug back in and make the equation work, is 10 over 3. Okay, so next question. I'll go ahead and do the same thing. I'm going to make my sides of my equation really obvious. I'm going to ask myself, can I simplify the expression on the left side of the equal sign? To that I say yes. First, I'm going to distribute. Be really, really careful. We're going to distribute a negative 5. So I'm going to end up bringing down negative 3a, and then negative 5 times a is negative 5a, and negative 5 times positive 2 is negative 10. And then bring down the rest. Can I simplify? Oh, I can still simplify on the left. So I've got these two like terms. Negative 3a minus 5a is negative 8a, and then I'll bring down the minus 10, and the 8a plus 3. Now, do we have variables on both sides of the equal sign? We do. So I need to get them together by adding or subtracting the entire term. Since this is a negative 8a on this side, I'm going to prefer to add 8a. That way my variable terms stay positive. Whatever I do to one side, I do to the other. This cancels. I bring down a negative 10. 8a plus 8a is 16a, and then I can bring down my 3. Now, what's keeping my variable from being isolated? I've got 16 that's being multiplied and 3 that's being added. We're going to deal with addition and subtraction before multiplication and division, so I'm going to subtract 3 from both sides. Those cancel. Negative 10 minus 3 is negative 13, and then I bring down my 16a. Now, because 16 is multiplied by a, to get rid of it, I'm going to divide. Whatever I do to one side, I do to the other, and I'm left with a is equal to a negative 13 over 16. All right, let's go ahead and move on. So now what do we do if there's fractions involved? Remember, before you cancel all your fraction terms, you have to do any distribution. And we do have some distribution here. So I'm going to go ahead and keep the fractions for just a minute. So 1/2 x, and then 4 times x is 4x, and 4 times negative 1 is negative 4. And then on the right side, 2/3 minus 5x. So now that I have dealt with all the distribution in the entire equation, at this point I can multiply the entire equation by the least common denominator. So we only have two denominators showing right now. That's because the rest of the denominators would all be 1. So we really only need to consider the 2 and the 3. So the least common denominator with 2 and 3 is going to be 6. So I'm going to multiply the entire equation, every single term on both the left and the right side, by 6 over 1. So 6 over 1 times 1 over 2 is 6 over 2x. 6 over 1 times 4, we can just at that point say 6 times 4 is 24x. 6 times negative 4 is negative 24. All right, on the right side, don't forget you've got to multiply both sides. So 6 times 2 is 12, and then 1 times 3 is 3. And finally, 6 times negative 5 is negative 30, and it's an x term. Okay, so it looks even messier now. But if you recognize here, 6 over 2 is 3. And on the other side, 12 over 3 is 4. So now we have an equation with no fractions, which I don't know about you, but I like. So can we simplify the left side of the equal sign? We sure can. We've got like terms that we can combine to be 27x. I'll bring down my minus 24. We don't have any like terms or distribution on the right side, so I can just bring down my 4 minus 30x. Now, do we have variables on both sides of the equal sign? We do. So I'm going to go ahead and choose to add 30 to keep my variable terms positive. Whatever I do to one side, I do to the other. Negative 30 plus 30. That cancels out, so I end up with 4 left on the right. 27x plus 30x is 57x minus 24. Now, what's keeping the variable from being isolated? We've got a 57 that's being multiplied and a 24 that's being subtracted. We're going to deal with addition and subtraction before multiplication and division. So I'm going to add 24 to both sides. Now I'm going to have 57x is equal to, those two cancel, is equal to 28. And then let me pull this up over here. We've got 57x equals 28. What's keeping x from being isolated is a 57. It's being multiplied, so to get rid of it, we divide. Whatever we do to one side, we do to the other. We're left with 57 over 57. That simplifies down to 1 or 1x, which is what we want. And we have 28 over 57. Okay, next example. So this example looks a little bit weird, but we're still going to use the same procedure for solving it for the most part. So first thing you want to look at is if you have any place where you need to distribute, and we don't have anything to distribute. So we can go ahead and immediately try to cancel out all of our fractions. So I'm going to go ahead, I'm going to look at all of my denominators, and the least common denominator is actually going to be 12, or 12 over 1. So now we're going to multiply every term by 12 over 1. So 12 times negative 5 is negative 60, so negative 60 over 1 times 3 is 3, plus 12 over 1 times 1 over 4, so that's 12 over 4x. Now is equal to 12. Here's the deal. What I would do on that other side, since the 2x minus 2 is grouped, is I would go ahead and leave it like this. 12 times, and then I would just leave it as 2x minus 2, and then 1 times 12 is 12. The reason that I would do that is because now at the next step I can just cancel the 12s, and I'm just left with 2x minus 2. So let's go ahead to that next step, and we can simplify our other remaining fractions. Negative 60 over 3 is negative 20, plus 12 over 4x is 3x. Is equal to, and then all we have left is this 2x minus 2. So now, do we have, first, can we simplify the expression on the left? We can't. Can we simplify the expression on the right? We also can't. Do we have variables on both sides of the equal sign? To that, we say yes. So we're going to get them together by adding or subtracting the entire term. Because that 2x is a positive 2x, I'm going to do minus 2x, and then whatever I do to one side, I do to the other. 2x minus 2x is 0. So on the left side, I'll bring down my negative 20. 3x minus 2x is a plus 1x, or just plus x, and then I'll bring down my negative 2 on the right side. Now, what's keeping x from being isolated is that negative 20. So to get rid of it, we're going to add 20. Whatever I do to one side, I do to the other. And although the question itself was super messy, you actually had a not so messy answer. Okay, last couple. So here, we did one of these, something similar to this on the last video, but we didn't have variables on both sides. But I want you to notice that we have kind of a fraction or a ratio set up where it's like a numerator and a denominator on the left side is set equal to a numerator and the denominator on the right side. So remember, we can cross multiply. So go ahead and we're going to multiply 6 times 3w minus 4 and say that's equal to 7 times negative 7w minus 1. So now let's go ahead and simplify. Now it doesn't look so bad. On the left side, we can simplify that expression by distribution. So 6 times 3 is 18, so 18w minus 6 times 4 is 24. On the right side, 7 times negative 7 is negative 49w, and 7 times negative 1 is negative 7. Now we have variables on both sides of the equal sign. So what we're going to do is we're going to add 49 to both sides. It would not be wrong to subtract 18 from both sides, but then you'll have a negative variable term. So I don't prefer it. So on our left side, we have 18 plus 49w, and that gives us a 67w. I'll bring down my minus 24. On the right side, these cancel each other, so all I have left is a negative 7. Now, what's keeping our w from being isolated? There's a 67 that's multiplied and a 24 that's subtracted. We're going to deal with addition and subtraction before we deal with multiplication and division. Here, negative 24 plus 24 makes 0. We can just bring down the 67w, and negative 7 plus 24 is 17. Now, w is being multiplied by 67, so to get rid of it, we divide. Whatever we do to one side, we do to the other, and we are left with w is equal to 17 over 67. Okay, and finally, this one is what I would call a special case. So I'm going to just work through it, and then we'll talk about it after it gets kind of weird. So can we simplify the expression on the left side of the equal sign? To that we say yes. We've got a 2 that we can distribute, so 2 times x is 2x. 2 times negative 1 is negative 2, and then plus 5x. We can continue simplifying by combining our x terms. So 2x plus 5x gives us 7x, and then minus 2 is equal to. On the right side, can we simplify the expression? We can. We can distribute the negative 3 and get, I'll bring down 10x. Negative 3 times x is negative 3x. Negative 3 times 8 is negative 24. Now we can continue simplifying by combining the two variable terms. 10x minus 3x is 7x. And then we'll bring down the minus 24. At this point, you might go, well, that's a super weird equation because it's saying that if you take 7 times x and you subtract 2 from it, it's going to equal the 7 times the same number and you subtract 24 from it. At that point, you should know there's a problem with this equation. Not a problem in your solution. It's not a problem in your procedure, just a problem with the solution. So if you don't notice that, that's okay. We're going to go on and continue our procedure. So do we have variables on both sides of the equal sign? To that we say yes. So I'm going to subtract 7x. Whatever I do to one side, I do to the other. And notice what happens at this step. Not only did we cancel the x term on the right side, but we also cancel the x term on the left side, and we're left with negative 2 is equal to negative 24. Okay. Super weird answer. It's like, well, that's not true. That's a false statement. Negative 2 will never, ever, ever, ever be equal to negative 24. What that tells us is that this equation has no solution. In other words, you could try forever and ever to find a number to plug in for x that would make this side of the equation equal that side of the equation, and you will never, ever find one. So this is called a special case. So let's talk about those special cases. The special cases happen when, while you're solving, your variables disappear. In other words, in the process, you end up canceling out all of your variables. There's two different things that you're going to see after this. So you're either going to have a solution that, well, the lack of a solution, so you'll have no solution, which means that no value of x will work. Or you'll have a solution of all real numbers, and what that means is that any value of x will work. Okay, and I'll give you an example of that in just a second. So how do you know whether your special case is a no solution or an all real number solution? It depends on what your final statement is. If your statement is false, for example, if your statement is 5 is equal to 4, which it's not, negative 1 is equal to positive 1, which it's not, 75 is equal to 1024. If you have a nonsense statement, then that means it's a false statement, so you're dealing with an equation that has no solution. If, on the other hand, you have a true statement, a statement where no matter what, it's always going to be true, like, for example, 5 equals 5. Yes, it does, and it always will. Or negative 1 equals negative 1. Yep, it always will too. 0 equals 0. Be careful with that one. When we see the number 0, we think no, and a lot of students would say no solution. But 0 equals 0 is a true statement. So therefore, if you see statements like this at the end of your equation, what you need to say is that the solution is all real numbers. That means that you can pick any number you want to for x, and it's going to work when you plug it into the equation. All right, I'll see you next time.